I'm going to show how to do a simple open pocket with SolidCAM's iMachining. I'm going to open a SolidWorks part file. I'm going to start a new SolidCAM milling project. I'm going to store all of the milling data inside the SolidWorks original part file. The coordinate system, stock, and target have all been defined. I'm just going to make a new material database for aluminum 6061. I just need to enter the ultimate tensile strength of the material. Select it from the list. Now I'm going to do a new iMachining 2D operation. Have to define the geometry. In this case, I want to use multi-chain for a face, and I want to mark the outside of the face as open. When I accept that, our two chains have been built, the open chain for the pocket and the island. I'm also going to pick the top of the stock and the pocket depth. Now I need to pick a tool. I'm just going to use a 1/2-inch tool and 4 flute. Right, our levels have been defined. Next we can take a look at the technology wizard, where all the speeds and feeds have been generated based off the material database that we've created and the machine definition. The default aggressiveness or machining level is at 3. So let's calculate the toolpath and see what we get. Let's take a look at the wireframe. What we see is iMachining's morphing spiral technology. We cleared the two furthest extremities. Then we created our morphing spiral, which morphs between a minimum and a maximum step over. Now we can adjust the morphing spiral with the efficiency slider, and let's slide it up to 10, which will create a more efficient spiral, which means that the step over will be more towards the maximum step over. Let's take a look at the toolpath. So what we have now is more of the external being cleared away first before our morphing spiral. And our morphing spiral is now more consistent of a step over. We can also go the other way. Let's bring the efficiency down to 1. So with the efficiency down to 1, we now have one spiral that was able to be created from the outside to the inside. Now when we reduce the step over from the maximum, we increase the feed rate to maintain a constant chip thickness. Let's take a look at the G-code. And we can see that the feed rates are varying as the step over changes to not lose efficiency. The idea with the morphing spiral is that the tool stays in contact with the material as much as possible, and the machine is moving in smooth tangent motions. And depending on your machine and repositioning ability, you may want to play around with the efficiency of the spirals. Now let's also say we want to finish this island. So we can save and copy that operation, and we can change it to the iFinish technology. Calculate the toolpath, and let's see what we get. And we get our finished toolpath around the island. All speeds and feeds have been generated by the technology wizard. Here you can see all the feed rates that have been created. Some of them are locked due to synchronization between the spindle speed, step over, and feed rate. Other ones are able to be edited if necessary. And let's take a look at solid verification of both of these operations. Just going to select both of them, turn on the solid verification. And there is our final toolpath. Let's close the part. And let's look back at the original SolidCAM part file that has all of the data stored in it. So when we open it back up, it asks if we would like to also open the CAM part that's stored inside. And I'm just going to say OK. And now we back to our milling CAM project.